Temperature. What do you mean by temperature? Of course, temperature means we can say that it is a measurement of hotness or coldness of an object. Everyone can say the basic definition. Apart from that, with respect to the internal energy, how we can describe the temperature. Let us see. When you strike a nail with a hammer, it becomes warm. Why it is so? When you put a flame to a liquid, the liquid becomes warmer as its molecules moves faster. Why it is so? That you need to know. In both the examples which I have seen in the screen, the molecules are made to race back and forth faster. It's, we can say that it's in rigorous motion. In this vigorous motion, what is happening? That's a motion for that. In other words, they gain kinetic energy. In general, the warmer an object, the more kinetic energy its atoms and molecules possess. As it warms, more kinetic energy as well as its atoms and molecules is possessed. More kinetic energy because of that, more vibrations as it acquired the heat energy. Now, as I said just now, temperature, the degree of hotness or coldness of an object. How it is? How can you say that? That I can say because of it is proportional to the average kinetic energy of the atoms or molecules making it up. How it makes up? It vibrates. The average, the measurement of vibration of average kinetic energy of molecules, we can call it as temperature. Okay, that's why we can say it is, instead of telling that measurement of hotness or coldness of an object, it's a measurement of vibration of average kinetic energy of molecules or atoms. We can say this all temperature. How can we measure the temperature? We can say that thermometer simply, right? Temperature can be measured exactly, depends on the kinetic energy per molecule due to its random motion. Okay, kinetic energy per molecule due to its random motion we can able to measure. Let us say we have a scales that is worldwide Celsius scale, Celsius thermometer we say it is. It is from which is consists metallic liquid mercury, and at the same time from 0 degrees Celsius to 100 degrees Celsius we are having the melting point as well as boiling point in that thermometers that we call as ice point is at 0 degrees Celsius and 100 degrees Celsius is a steam point in the mercury thermometer, right? So that you can see in the picture also on screen that 100 degrees Celsius, 0 degrees Celsius, ice point and steam point. We can say on the scale minimum point and maximum point, or lower fixed point at bottom and higher fixed point at the top. We can say it is. Now, how can we measure the temperature? In the US, the number 32 is traditionally assigned to the temperature at water freezes usually, and the other number is 212 is also the temperature at which water boils. This thermometer is called as Fahrenheit thermometer scale. This Fahrenheit thermometer is a scale which is used in US earlier. Of course, we have one more scale is so as I said, upper limits of these two scales with respect to principle, there is no upper limit to any temperature. Different scales will give different. But basically degree Celsius scale to understanding purpose with respect to water, we have given upper limit and lower limit only. Okay, you know, till now we were discussed three states before in previous video, but now the fourth state, actually it is not, it is, we can say fire as a plasma state, but it should be exist. That's why there are some properties lacking. That's why it will not be considered more as a fourth state. But scientists used to say are telling present, but still it needs to fulfill its properties. As thermal motion increases, the solid object first melts, then vaporizes usually. As the temperature is further increased, molecules dissociate into atoms, and atoms lose some of their electrons. Thereby what happened? Creating a cloud of electrically charged particles. The cloud of electrically charged particle is called as plasma state. Okay, this is happens because of higher energy. Whatever the atoms lose the electrons, thereby the there some cloud has created by electrically charged particles, that we say is plasma. Plasma state is existing where the complete rigorous burning is happening, like in stars, where the temperature is many millions of degrees Celsius. Okay, so at that state we can say plasma. Lower limits of temperature. That's why we won't have any maximum limit of temperature. It's ultimate. Depends on heat energy. We don't know core part of the sun, core part of the star. Same way, lower limits of temperature. What are the lower limits? We consider 0 degrees Celsius in a Celsius degree scale with respect to water at our day-to-day life. But actually, is that lower state? Let us see. In contrast to higher temperature, there is a definite limit of the opposite end of the scale also, that we call as absolute zero Kelvin. We say it is absolute zero temperature. Okay, temperature is described based on random motion of the molecules and its kinetic energy, right? The colder something is, that the slower the molecules. Okay, eventually, if the molecules will slows down so much, they'll essentially stops. Okay, slows down at particular point, gets stops moving and stops vibrating, even starts just displacing also. So that we can consider it is slowing down, is coming to the rest, in the sense it will not exhibit or it will not possess any amount of energy, right? So that we can consider as absolute zero or absolute zero temperature. This is Mr. Kelvin was found this earlier. He was a professor. To understand further the temperature, to find the lower fixed point, he has come down as a student and he found this. That is absolute zero temperature. It is for the water case, we can say that minus 273.16 degrees Celsius in terms of degrees Celsius. That we consider as zero Kelvin temperature. Okay, that you can see the measuring temperature, the scales you can see very clearly. 212 is a maximum for the Fahrenheit scale, and 100 degrees Celsius upper fixed point, and 373 Kelvin is upper fixed point with respect to comparison of these three scales. Okay, and water freezes usually with respect to water lower fixed point 0 degrees Celsius in Fahrenheit scale 32 degree Fahrenheit, 273 Kelvin. In Kelvin we will not use degree. 273 Kelvin we say, because Kelvin scale it is having the process also further. That's why we say it is Kelvin. Okay, if you want 0 Kelvin in the case of water, that is at minus 273. In terms of Fahrenheit, it can be minus 459 degree Fahrenheit. This is the most important to understand comparison. Okay, this is all about the temperature and temperature scales. We can also convert one scale to another scale with comparison, with consideration of one length into another scale. There is a formula also for that. We know very well. Thank you.